All right, so let's look at this question. It says, how many moles of oxygen are present in 16 grams of oxygen gas? How many moles of oxygen are present in 16 grams of oxygen gas? So, from the question, that picture I sent to us, you see relationship between mass and moles. Say the reacting mass, the mass divided by the molar mass. See how many moles of oxygen are present in 16 grams of oxygen gas. Now, oxygen is 16 grams. If it's oxygen like this, it's 16 grams, but oxygen is usually diatomic. So it becomes 16 grams times 2 for you to get the mass of 1 mole. So this 32 grams is the molar mass. That is the mass of 1 mole. Now, it said present in 16 grams of oxygen gas. So it's going to be half because this is molar mass. See, molar mass is 32, the mass of 1 mole. Now, how many moles are present in 16 grams? So it will be half of that. So now, this next example, what's the mass of 0.25 mole of calcium? What is the mass of 0.25 mole of calcium? Now, we know that calcium is the 20th element, and I told you that most times the relative molecular mass or molar mass is usually the atomic number, which is 20 times 2. All right, times 2, except that substance has a major isotope like chlorine, so it will affect the relative what we call the formula mass, or rather the relative atomic mass, because calcium is not diatomic. So calcium is simply calcium. So it's going to be 40. 20 times 2 is 40. This is the mass of 1 mole. You can say 40 grams of calcium. Remember 40 grams. So it's going to be mass of calcium is of course the number of mole times atomic mass of calcium. That's what that picture, the picture of mole has sent. All right. Another way to look at it, if you say molar mass of calcium is 40 grams, that is molar mass. You said, what is the mass of 0.25 mole of calcium? This is the mass of 1 mole. This is the mass of 1 mole. Molar mass or mass of 1 mole. 1 mole. Use your direct proportion. Therefore, 0.25 mole is going to be what you have here, the mass of 1 mole times 0.25. So use a direct proportion mathematics. If you do this, and this is going to get roughly 25 or 100. This is 25 or 100 times 40. All right, so that's going to give us 10. Yes, 10 grams. Now, how many moles are contained in 50 grams of magnesium trisulcarbonate 4? How many moles are contained in 50 grams of magnesium trisulcarbonate 4? They're giving us some some values. This is relative atomic mass of magnesium. This is the relative atomic mass of carbon, and this is the relative atomic mass of oxygen. How many moles are contained in 50 grams of this? Let's get the molar mass of magnesium trisulcarbonate. Magnesium trisulcarbonate is something like this. Let's get the mass of 1 mole. So it's going to be, this is a compound. So magnesium, we're given is 24. All right, so 24 plus carbon. Carbon is 12 plus oxygen. Oxygen is 16 in 3 places. So it's going to be 36 plus 48. That's roughly 84. 84 in 1 mole. All right, 1 mole of magnesium carbonate. Said how many moles are contained? 50 grams. 50 grams, let's say X moles. All right, so in magnesium, this is magnesium trisulcarbonate 4. We'll be able to calculate the what we call the relative molecular mass, because this is a molecule. It's not an atom, so we can't say relative atomic mass. We call the relative molecular mass of, or rather, formula mass. More technical, this is more of it's an ionic bond, so we don't call it molecule. We call it it's a compound. It's an ionic compound. All right. The formula mass. Formula mass is just a fancy word for relative molecular mass. All right. So formula mass is 84 grams. Although formula mass is a more formal term, so use formula mass for substances that are not covalent. All right, so 84 grams, we calculated it from the values given in the question. See those values given in brackets. They usually give you this relative atomic masses. Just use your knowledge of direct proportion in mathematics. So you can say if 84 grams is the molar mass, that's the mass of 1 mole. 84 grams has 1 mole of this substance is 4 grams. Then 50 grams is how many moles? You can just arrange it like this, and you can just use let's say 84. You can put this like into a fraction, 84 over 50, and then the right hand side you can put into a fraction 1 mole over x mole. Because say mole cancel mole, right? Just cross multiply, x goes here, and then 50 goes here, and then x comes down. Or sorry, 84 comes down. It was just cross multiply like mathematics. So x goes here, 84 comes down, 50 goes here. You're left with X like this. Point that into your calculator, you get 0.6 mole. All right. 50 gram contains 0.6 mole of this compound. Why 84 gram contains a whole mole of that. That's some of the applications of what we call stoichiometry, calculating mole ratios. All right. We're talking about 50 grams. 50 grams. Number of moles, 50 grams of calcium chloride. Calcium chloride is like this, of course. If calcium, so we're going to look at the relative. We're going to add up relative atomic masses of calcium plus chlorine, 2 times chlorine. So it's going to be calcium. Calcium is 40. Then this one is 35.5 times 2. All right, because you can see it's 2 atoms of chlorine. So this is going to give us 40 plus 71, and that's going to give us 111 grams are contained in 1 mole of this. So 1 mole of this, this is the molar mass. This is the molar mass or mass of 1 mole. The mass of 1 mole of the compound calcium chloride weighs 1111 grams. How many moles? Say 1 mole. Let me just say 1 mole in 111 grams. Therefore, 50 grams will give us X moles. Just say X. We can make X a for. Look at this left hand side like 1 over X, and equals to this right hand side 111 grams over 50. All right, so X crosses over 50 goes like this, and then so we can cross multiply. If we cross multiply, we have X comes here to the right hand side, then 50 crosses to the left hand side, and then 1 can also come down here. If you point that, you're going to get 0.45 mole. So that's the number of mole in 0.45 mole, number of mole in 50 grams. Hope that's clear. So just to recap, we have to get the molar mass. That's the mass of 1 mole by adding up the relative atomic masses, which are usually given the question. Calcium is 40, chlorine is 35.5. That's from another question. Applying that, 35.5 times 2 atoms to give you 71, plus relative atomic mass of calcium is 40. We get 111 grams. So 111 gram is equivalent to 1 mole. Then 50 grams equivalent to X. Find X, cross multiply, you get 0.45 mole. Let's look at this example. It says calculate the number of moles of calcium chloride that can be obtained from 30 grams of calcium trioxocarbonate 4 in the presence of excess hydrochloric acid. Then we're given some relative atomic masses of the elements. Now it says calculate the number of moles of calcium chloride that can be obtained from calcium trioxocarbonate 4 in the presence of excess. So you know that it's likely going to be a reaction between calcium trioxocarbonate 4 and hydrochloric acid to give you that calcium chloride as one of the products. We should get used to some of these reactions. So that's what the reaction looks like. Calcium trioxocarbonate 4 plus the HCl reacts to give you calcium chloride as stated in the question. Then water and carbon dioxide are the other products. All right. We are asked to obtain from 30 grams. Let's get the mole ratio. So make sure that this is a balanced equation. So you have 1 calcium here, 1 calcium here, 1 chlorine, 1 chlorine. No, 1 chlorine, 2 chlorine, but that's why we have 2 there. 2 will multiply everything out, double everything. We have 2H. Oxygen is 3. Oxygen is 1 here, 2 here. So 1 plus 2, 3. So oxygen is balanced. They say the equation is balanced. Now from the equation, 1 mole of calcium trioxocarbonate yields 1 mole of calcium chloride. All right, so we have to understand that number of moles of this that can be obtained. We have to calculate number of moles of obtained from 30 grams of this. So we're going to compare 30 grams of this and number of moles for this. Grams in mass or mass in grams, the number of moles for this. Let's get so this is for this balance equation, we're looking at 1 mole of this will produce 1 mole of this. We're going to convert 1 mole to molar mass and convert 1 mole of this to also molar mass, because we're looking at number of moles of this obtained from 30 grams of this. So this is 1 mole obtained from the molar mass of calcium trioxocarbonate 4. Let's get the molar mass of this that is producing 1 mole of this. Once you get that molar mass, then break it down to 30 grams and to give you the number of moles that comes out of 30 grams. As it is right now, we have 1 mole coming out the molar mass of this. This is going to be 40 plus 12 plus 3 times 16 oxygen. Right, so let's conclude this question. From the balanced chemical equation, we have that You understand that the number of moles of this calcium chloride that can be obtained from 30 grams of this. We're going to compare mass in grams to mole. This one, we know that we've calculated this one before us. This is going to give us 40 plus 12, that's 52. 52 plus 3 times oxygen. 52 plus 48. 3 times oxygen is 3 times 16 is 48. So 52 plus 48 is going to give us 100. There are 100 grams in 1 mole of this. So that's the molar mass. There are 100 grams in 1 mole of this. So the molar mass of this substance is 100 grams. Calculate the number of moles of calcium chloride. Now, we have, so basically for what we have here, that means we have 100 grams, it gives us 1 mole here. So 100 grams here produces 1 mole here. Therefore, 30 grams, you can use a direct proportion. So I'm going to say that 100 grams, let's get 100 grams of calcium trisulcarbonate 4 produces 1 mole of calcium chloride. Therefore, 30 grams of calcium trisulcarbonate 4 produce, let's say, X mole of calcium chloride. You can make it into a mathematical expression like this: 100 over 30 equals to 1 over X. All right. So your answer will be in mole. So you can cross multiply. X goes over here, and 30 goes here. 100 comes down, so that X stands alone. Gram cancels gram, and this is going to give us 0.03 mole. Should look at it. There are 0.03 mole of this in 30 grams of this. Just like there's 1 mole of this in 100 grams of this. Now, how do we get this? From our balanced chemical equation. This balanced chemical equation is very important for reactions. So we've studied the stoichiometry of this reaction, right?